Hello everybody, welcome to InterviewBlog. In this video, we'll be covering the question contains duplicate. So the question gives us an array of integers and it wants us to write a function to determine whether the array contains a duplicate value. So first of all, what is a duplicate value? In an array, if an integer occurs more than once, then it is considered to be a duplicate element. For example, in this given array, we can see that the numbers 1 and 2 are repeated. That is, it occurs twice in this array. And so our function should return true. Now let us consider another array which contains 1, 2, 3, 4, and 5. Now for this array, our function should return false since there are no duplicates in this particular array. Now let us see how to solve this problem. So to solve this problem, I'll be using an auxiliary data structure. So an auxiliary data structure is a helper data structure, which is actually going to help me solve this problem. So I'll be using an hash table here. So hash tables are nothing but dictionaries in Python. So what I will do now is I'll be traversing the elements in my input array one by one. And for each element, I'll be checking if the particular element is present in my hash table or not. If the element is not present in my hash table, then I'll be adding that particular element to my hash table. But if the element is present in my hash table, then it means that we have already encountered the same element before in our input array, and hence we have added that element to the hash table. And now we are encountering the same element again. So our array contains duplicate, and hence we would be returning true. So when does our function return false? If we have traversed the entire given input array, it means that our input array consists of distinct integer values and it has no duplicate values. Hence, in this scenario, our function will return false. Please note that I can also use a set instead of this hash table. Let us now work out this particular example. My first step would be initializing a hash table or a dictionary. Now, what will I do is I'll be traversing the elements in this array one by one. First, I will go to this one. I will check if this one is present in my hash table. And since this one is not present in my hash table, I will add that particular value to my hash table. Next, I'll be visiting this 2 and I will check if this 2 is present in my hash table. And since it is not present in my hash table, I will add 2 to my hash table. Now, I'll go to this -4 and check if this -4 is present in my hash table. And since it is not present, I'll be adding this -4 to my hash table. Next, I'll be going to 0. I'll check if this 0 is present in my hash table. Since it is not present, I'll be adding this 0 to my hash table. Next, I'll go to this 1. I'll check if this 1 is present in my hash table. Since 1 is already present in my hash table, my function would be returning true. Please note that there is no requirement for me to traverse the remaining part of the array, since I have already found a duplicate value. Let us now work out another example. In this example, the given input array consists of integers 1, 2, and 3. So my first step would be initializing an hash table. Now I'll be traversing the given input array and I'll check if the given elements are present in the hash table or not. Now I'll go to 1. I'll check if this 1 is present in my hash table. And since 1 is not present in my hash table, I'll add that particular element to my hash table. Next, I'll go to this 2. I'll check if this 2 is present in my hash table. Since 2 is not present in my hash table, I will add this 2 to my hash table. Now I'll go to this 3. I will check if this 3 is present in my hash table. Since 3 is not present in my hash table, I will add this element to my hash table. Now, as you can see, I have completed traversing the entire given array. Since I have completed the traversal, my function would now return false. Now, why does my function return false? Because there are no duplicates in the given input array. And all the elements present in the given input array are distinct. Therefore, our function returns false. So hope you understood the solution. Let us now analyze the complexity of our solution. The time complexity of our solution tends to be big O of n. and the space complexity of our solution tends to be big O of n, where n is the number of integers in the given input array. So why does our time and space complexity tend to be big O of n? We worked out a scenario where our input array consists of integers 1, 2, and 3. In this case, we traverse the entire array and found that there are no duplicates in this array. And since we are traversing this entire array, the time complexity tends to be big O of n. In the same case, while traversing, we are adding all these elements to an auxiliary data structure, which in this case, we used hash table. Since we are storing all these elements in a hash table, our space complexity tends to be big O of n. So before diving into the code walkthrough, let us now see another scenario where the given input array is sorted. Let us now take a scenario where the given input array is already in a sorted fashion. In this case, I won't be requiring any hash table or set to solve this problem. I can solve this problem using simple two-pointer technique. In this case, my first pointer will be pointing to the 0th index of the given array, and my second pointer will be pointing to the element which is present in the first index of the given array. Now, what I'm going to do is, if P1 is equal to P2, then I'll be returning true. If not, I will keep on traversing the array. So in this case, what I'm going to do now is, first I will check if the elements present in P1 and P2 are equal to each other. Now 0 and 1 are not equal, hence I'll be moving these pointers one step further. In this case, 1 is equal to 1, and hence our solution returns true. Let us now consider this scenario. In this scenario, the elements present in the pointers P1 and P2 are 0 and 1. And since they are not equal, I'll be moving these pointers one step further. Now they are pointing to 1 and 2. Now, since they are not equal, I'll be moving my pointers one step further. Now 2 is not equal to 3. Hence, I'll be moving the pointers one step further. Now, since 3 is not equal to 6, I will again be moving my pointers one step further. Now, since 6 is not equal to 8, I will again be moving the pointers one step further. And now, since the pointer P2 has traversed the entire array, my function here would return false. Let us now analyze the complexity of this solution. The time complexity of this solution tends to be big O of n, where n is the number of integers in the given input array. So why it is big O of n? Because in this scenario, the pointer P2 traverses the entire array. Hence, my time complexity tends to be big O of n. The space complexity of our algorithm tends to be big O of 1. So why is it big O of 1? Because we are not using any auxiliary data structure like hash table or set. We are using just two pointers to finish our solution. Hence, our space complexity tends to be big O of 1. Please note that this two-pointer solution can be used only when the given array is sorted. If we sort the given array, then our complexity of sorting the array tends to be n log n, which increases the time complexity, and hence our first solution is already the best solution. Let us now see the coding implementation of this problem. All right, so we got our contents duplicate function defined, which takes in an array. Please note that we are going to cover the solution where the input array is in unsorted fashion. As I already explained in the explanation part, I'm going to use an auxiliary data structure to solve this problem. So I'll be using a hash table in this case. So my first step would be initializing an hash table. Now I'm going to traverse the elements of the array one by one. So I'm going to say for element in array. And now I'm going to check if this element is present in the hash table or if this element is not present in the hash table. So I'm going to handle these two cases. So if element in hash table, then what I'm going to do is I'll be returning true. Why am I returning true? Because I have already encountered the same element in the array, and hence the array has a duplicate value now if it is again found in the hash table. Hence, I'll be returning true. If the element is not present in the hash table, then I'm going to add that element to the hash table. So hash table of element is going to be true in this case. Now, after traversing the entire array, if I still do not find any duplicates, I will be returning false. So this will be my solution, and this solution runs in big O of n time and big O of n space. Where n is the number of integers in the input array. So why is the time complexity big O of n? Because when the array contains no duplicate values, we will be traversing the entire array. So all our integers present in the array will be visited once. Hence, the time complexity tends to be big O of n. And why is the space complexity big O of n? Because we'll be storing all these elements in the hash table if there is no duplicate value. Hence, our space complexity tends to be big O of n. So let us now test our solution. So I'm going to just copy this solution. So this is Leetcode problem number 217, which is titled as contains duplicate. And it is the same problem that we discussed so far. So I'm just going to paste my solution here. Since the function names are same, I'm going to change our function to contains duplicate 1. And now what I'm going to do is align, and I'll be returning contains duplicate 1 of nuts. So our solution works good. Let us now submit our solution and check whether it passes all the test cases. So yes, our solution got accepted. Let us now discuss the solution when our given input array is in sorted fashion. So now we will be discussing the solution. The input array is in sorted fashion. Let me comment out this. Let us now discuss the solution when our input array is in sorted fashion. So our contains duplicate function now takes in a sorted array. In this case, as I already discussed in the explanation part, I'll be using 2 pointers, that is P1 and P2, where P1 points to the 0th index of the given input array and P2 points to the first index of the given input array. So as I already discussed, I'll be traversing till P2 traverses the entire array. So while P2 is less than the length of array, I'm going to traverse and I'm going to check if the element present in the index P1 and if the element present in the index P2 are equal. Here I'm going to change it to sortable. If both the elements are equal, then our function should return true because it has found the duplicate value. Else, we will just keep on traversing, that is incrementing the pointers by 1 position. After traversing the entire array, if we do not find any duplicates, we have to return false. So this solution has a time complexity of big O of n and a space complexity of big O of 1, where n is the number of integers in the input array. So why is the time complexity big O of n? Because we will be traversing the entire array if our array contains no duplicates. And why is the space complexity big O of 1? Because we are not using any auxiliary data structure. We are just using 2 pointers to solve this problem. So once again, I'm making this point. Please note that this solution works only for a sorted array. So let us now test our solution. Let us have an array which has a duplicate value like 0, 1, 1, 2, 3, 6, 6, and 7. So let us now test our solution. So our function returns true since our array contains duplicate values. Let us now remove the duplicates and check our function. Now our function returns false. Hence, our solution works good. Hope you understood the problem. Do subscribe and check out our channel for more videos. Thank you so much.